All right, we're going to write an algorithm that finds the lonely integer in a sorted array that has duplicates, and one of the numbers in the array is not a duplicate. So something like 1, 1, 2, 2, 4, 4, 5, 6, 6, 7, 7, something like that. So I'll go ahead and get our number, our indexes ordered as well. And then let's actually get a darker color here. So what we're going to do is we can use a binary search to determine this. So the first thing we would do is find the midpoint. And then if the index, we can use our indexes to our advantage because we can predict what it should be. So if the index, I should say if mid is odd, then we want to look left for its pair. Look left. And if you find a pair, then we know that everything's in the right position. So if we were here and we're looking left at the 4, then we would know, okay, those match. Everything must be lined up correctly on the left side in order for that condition to be true. So in that case, we would want to look right. So throw away left. And then if mid is even, we look right. And if there's a match, we want to throw away the right. Okay, so the first thing we can do is write kind of a helper function or kind of the main one. So public, it's going to return what the unloading integer is. And we can say find lonely. And it takes in an array of ints. Okay, and it can do a couple little quick tests. So if array.length equals 0, or array equals null, then we can throw an exception. Okay, and so we'll be throwing an exception there. Also, if array.length is even, then we know that there's something wrong, because it has to be an odd length, because there's going to be all pairs except for one number. So we could also throw an exception there. And then also the thing that we want to check right off the bat would be if we could do it if it's one number, which would mean that that would be the answer. So then return array 0. Okay, so we've done a bunch of checks, and then what we can do is at the very end, we're going to make like a search function. It's going to take in the array. It's going to have a left, and the right's going to be array.length -1. Okay. So let's go ahead and write our search function. I'm going to start it over here so that we have a little bit more space. So public, and it returns the integer that's lonely. And we're taking in an integer array, the left and the right. Okay, so off the bat, our base case is if left equals right, then we know we've kind of gone through the whole, we've gone through everything, which means that we can return the element in that spot. And so that would be array at left. Okay. All right, so then after we do that, then we can go in and we can calculate our mid. So int mid equals left plus right divided by 2. All right, and then we can go in and we can say if our mid, we want to find out is our mid odd or even. So if mid mod 2 is odd, then we decided we want to look left. So then, so if array at mid equals array at mid minus 1, then we want to do the search. And this time we are looking at the right side. And let's keep the right. And then otherwise, we want to look at the left side. So left stays the same and we get mid minus 1. Okay. And then that's if it's odd. If, or we can actually just do a big else because that's the only other case. So else it's an even, which means we want to look to the right. So else if array at mid, oh wait, no. Yes, if a mid equals array at mid plus 1, then we're going to return search, and we want to just look at the right side. So we would do search and we'd say array, we'd say left becomes mid plus 2 because we can skip over the extra 1 since they match, and then right. So else return search, and this one just looks at the left. Okay, so that should take care of it. Let's go through and we can double check and test it out. So let's draw one of our stack to go through this. Okay, and I'm going to grab a different color so we can see what we're doing. All right, so if our array starts here, we're going to go in and it's going to be left is going to equal and start at 0. Right starts at array dot length minus 1. So that starts at 10. And mid will be calculated out to 5. So we start here. And if mid mod 2 equals 1, which it does, then we come in. If mid equals array at mid minus 1, which it does, so we go in and we're going to have 1 is here. And we end up getting left being mid plus 1, which is 6. So this becomes our left. And right stays the same, 10. And then mid is calculated out, and so it's going to be 6 plus 10 is 16, divided by 2 is 8. So now mid is 8. Okay. So we come in, if mid mod 2 equals 1, well, that's not true, so we go into our else. If array at mid equals array at mid plus 1, so if array at 8 is 6, if it equals the 7, which it does not, so we're going to return here, and we're going to go in and we're going to say left is still 6 and right becomes mid, which is 8. Okay, and then we'll end up going through, and left and right are not equal, so mid is now going to be 6 plus 8, which is 14, divided by 2 is 7. So our mid is now here. And then we come in, and if mid mod 2 equals 1, which it does, then we come in. If array at mid equals array at mid minus 1, that's not the case. So then we go in and return here. And it's going to take in array at left. Array left is going to be the same. And right is now mid minus 1. So that is now 7 minus 1, which is 6. And then we come in. If left equals right, which it does, then we return array at left. So we return array at 6, which is the 5, which is our lonely integer. So we have been able to perform that correctly. We were able to do it in just 4 iterations, which was much better than walking through the entire array. And since we're using the binary search, we're dividing our data set in half each time, then our big O is O of log n. And we took up 0 extra space.